Okay, very simple question. You can answer quickly. I'm giving simple one beginning so that you have a clear idea about what is happening and how you differentiate between different types of forces and its stresses, right? So that you can answer for the given question. So internal diameter is given as 350, external diameter as 450. So when you write the given data for solving any problem, you should start with given data. You are given with number one, the load, compression load is given. PCN compression load is given as 1200 kilonewton, right? 1200 kilonewton. Okay, and then for let me check the tablet mode. Okay, and then what else? Given diameters are given for getting the area, and then what else? What type of stress is it? Because compression load, so it will create compressive stress. That's the answer. Developed in a hollow tube due to this loading, and how much is the value. So you need to find out how much does compression stress produce. This is the question. Diameters are given to know the area. First of all, do you understand why it is compressive? Anybody? Can you answer? Please, all of you switch on your camera and then join the class. Let me see. Take photograph also. Please make it interactive. Huh? Cool evening. I'm sorry for troubling today. Next time onwards I stick to the timing because we had one seminar this morning. It had extended until 1 o'clock, 1:30. I cannot close it. Cannot leave in between because from the ministry they are talking. I have to cancel this or postpone our class. Can you please tell me what is this? What do you call? All of you switch on your camera. Let me also join and you can follow. Are you working? What is the answer for this? Come on, answer me. Quick answer. Very simple question I started with. Why it's compressive? Number one, I asked why it's compressive. Because you see the direction of the force acting 1200 kilonewton as see you can see my cursor moving 1200 is acting in this direction. The material, this is showing the cutting section. The full this is the full body, okay? The hollow tube start from here and ends here. It is showing the cutting section. So it is subjected to a compressive stress, or due to compression load it will be subjected to compression stress. It means it is acting towards the area, right? It is producing the load is axially loaded in one direction. It will cause a normal stress, right? The material will start behaving reacting like this, isn't it? Normal, okay? And perpendicular to the area. See the area of cross section. It is acting perpendicular to the area, and then it is still inside the body, isn't it? It is not trying to extend, but created inside the body or in such a way that reducing the size of the body, okay? Reducing the height of the body or length of the body. It is compressive in action. That's why it's called compression load. In other words, the load is acting inward, right, or towards the body, towards the area of the surface on which it is acting, surface or area on which it is acting. It is not away from the surface, away from the body. If it is away from the body, you will take it as, yes?
Are you writing something?
No, I'm not writing anything.
Okay, because it's not working.
You can see my the word file.
Yes.
I didn't write. You can see this cursor moving, the black one.
No, teacher.
Oh yeah, what's the problem? Now, one moment. You can see now.
No.
I'm not writing, but my writings are clear, right? You can see the writing, isn't it? You can see the writing, isn't it?
Yes.
Okay, let's move on. Because it's acting perpendicular to the surface area on which it is acting, it is called, and also in the way of reducing the dimension of the pipe, we call this as compressive stress. Okay, the solution is just one step. Compressive stress is equal to load and compressive load over the area on which it is acting. Let's find out the compression force or the area on which it is acting. What is the area on which it is acting? It's a hollow pipe. Huh? Remember, it is hollow pipe. Okay. How can you measure it? This is hollow means what? Inside no material, right? The material in action will be this thick portion, the thickness, right? To the thickness of this or the wall thickness is undergoing a compression for load or bearing the compression load, not the material inside. There is no material inside. It's hollow, already written as hollow material, right? The pipe is it's a hollow steel pipe. Hence, there is no material, so that the loading may be acting on to the ring or the thickness equivalent to difference between this diameter. So you need to take down this area only. Try to understand the area on which the compressive force is acting. All right. Okay. Let's find out the area. If you calculate the area, it will be okay. It's happening. Okay. Here, okay. Sorry. Okay. When you find the area of cross section, what will be the area of cross section in active or actively subjected to this type of loading? It is pi, right? This is a circular area, right? The area is in circular dimension, so it's pi r square or pi d square by 4. We can use either formula, right? The area is actually pi d square by 4 we can use, right? But the d is the nominal diameter. I mean, you have to find out the net diameter or nominal diameter. Nominal diameter means you need to deduct or take only the thickness of the diameter. I mean the thickness of the wall. How do you take the thickness of the wall? Capital D, diameter of the outside minus diameter of the inside square divided by 4. What will be the answer? Can you tell me the answer, please? What is the answer? Everybody please work out. Work out, please. What is the value of the area here? Pi. What is the diameter? Capital. I mean the bigger diameter is 350, right? Mm. Change to 450, right? Change to meter. It will be 4.45 minus 0.35 square divided by 4. Please give me the answer. Area of cross section or nominal area of cross section on which the compressive stress is acting, right? This can hardly act on this directionally. The net force is given by 1200 kilonewton, isn't it? The net force is given by 1000, or total force is given by 1200 kilonewton, which is here, right? Tell me the answer for this area. Are you working out? All of you join.
7.854 times 10 to the power of negative 3.
Okay. All are getting the same answer? Okay. Right.
7.854
into
negative 3.
negative 3. Okay. One moment. Okay, this is the area, net area on which it is acting. I got the area, I got the load. Now I can conveniently calculate sigma C, which is the same equation I'm going to use, equation 1. So I substitute in equation 1, which is sigma C is equal to Pz. Pz is our value of the load, 1200 kilonewton. Let it be kilonewton itself, then I can get it in kilonewton answer. 7.854 into 10 power minus 3. Please give me the answer. What is the answer? With this, the calculation is finished.
152.79 megapascal.
Okay, all are getting the same answer. Please check, everybody. Are getting the same answer? Any question in this? Very simple one, right? Having understood the direction of loading and surface on which it is acting, you need to exactly calculate the area. That is important. 19.10 megapascals. All are getting this answer. This is a correct answer for
Miss 152.79 megapascal.
15.
152.
Can you check others? Please check.
Yeah, teacher, 152788.
Okay, you need to change this one because this one is in meters, right? This one, how much is this? Change to newtons. 10 power 3. Can you solve this one? Can you solve this one? Is this in meter? This is in meter, right? Also in meter. Okay, meter square I will get. Is this answer correct? Area? Answer area is correct or not? Square, did you square? Pi d square by 4. Did you square? Double check your answer, all of you. Okay. We're getting 19 megapascals. That's the correct answer. Is the area correct? Meter square, right? It's in meter square, right? Should be in meter square. What are you doing? Please spend some time to work out. You may get some silly mistake. Did you square or divide? It's 1200, right? Oh, correct, only kilonewton. I changed to newtons already. Okay, I write clearly here. See, because we are changing to newton already. Please tell me the answer. Don't take much time. Newtons, and this is in meter square. Should be meter square because negative all the small values rise. Okay. What is the answer getting? Any other?
Miss, I get 152.79 megapascal.
Megapascal. All are getting the same answer? Any other answer? Okay.
Yes.
Let it be. I will check later. As long as your calculation is perfect, the divisions, I mean the area is correct. Please double check the area. Did you square and divide? Okay. As long as these numbers are correct, I will double check again. But my answer is 19 megapascals. So this is a book answer. Sometimes the book answer also cheating you. Don't worry. I will double check later on. I don't have the calculator right now. That's why I asked you to work out. Okay, I once again repeat the answer. 152.79 megapascals. Okay, I will check, double check later.
79.
79. What's happening? Undo. Okay. 79 megapascal is our answer. Okay, let it be. Now move on to the next question. Something similar to that. Just understand the type of loading only. You see here, the given is a metal tube, right? Similar to the last one, also a hollow tube, okay, and is loaded at the bottom. It's subjected to a tensile force. You can see that the load is acting away from the surface area, isn't it? That's why I can say it is subjected to a tensile force. So all of you understand the concept. When a body is subjected to a loading, it may undergo any type of deformation, either tensile or compressive or shearing, right? Depending on the loading and the material property, and also the what do you call the location, it will change. The failure mode may be all of them. You can observe compression, you can observe tensile, you can observe shear, or compression and shear, and so on. In this case, you can see the loading is 100 megapascals and meganewton, 100 meganewton. Why meganewton? One moment. It's 5, right? Let me change. Subject to force equal to 500. We jump the area. It's a load, cannot be like this. One moment. Oh, it's a. I'm sorry, I have to remove this one. The load is already given. It is 500 kilonewton. It's a load, kilonewton. So it is subjected to a load of 500 kilonewton away from the surface. So we understand that the given type of loading is should be tensile, causing extension of the material or elongation of the material. Right? The given data is similar to the last one. Let's see, we are getting correct answer here. Given data, you are given with the tensile load. Let it be T. T is equal to 500 kilonewton, and then the loading allowable tensile stress is given. Right? Allowable tensile stress is given this time. So this is sigma stress is given 150 kilonewton. Oh no, not kilonewton, meganewton. Oh, megapascals. Let's just write it as megapascal. That is confusing. Megapascal. 1 pascal is 1 newton over meter square. So I write it like this. Okay, 150 newton meganewton over meter square is 1 megapascal. So I write it as 150 megapascal. And then determine the outside diameter of the tube if the inside diameter is 125. So now the reverse learn the same procedure. Can you do and get me the answer before I finish? I hope some of you can finish it off. 125 inside is given, but outside is unknown. Clear? You don't know what is the outside diameter. Okay, question mark here. There is a question mark. You can use the green one. You don't know what is this value. Okay, let's find this one. Take the small one. Okay, solution will be very simple. Same like the last time. We work back and find out. Stress is given. Go from the known data. You know the stress is by formula. It is PT by AT, isn't it? The tensile stress, the area on which the tensile stress is acting on it. Come on, let's substitute one by one. Take some more area here. My keyboard. Where's the keyboard? So touchy like this. Okay, try to enter. My keyboard is missing. Okay. Write it. Come on, substitute the formula here. What is the load? Load is already there, but again the formula for AT will be here, and net value or nominal diameter needs to be taken. So that will be pi, right? Pi into something happening. Okay. All of you work out and get me the answer, please. Please try to get the answer. It's just very touchy. Get me the answer, please. I will check. I will work out later. Very simple one, straightforward. What's your answer?
190 mm.
Okay. So when you substitute here is the outer diameter, right? Outer diameter minus inner diameter square, huh? 5d square by 4. Where is my drop? My file is missing here. One moment, my drop tool is missing here. I'm sorry. You cannot hear me? Oh, sorry. Why you didn't tell my mic is mute? I keep talking now, only I check it's mute. Okay, are you getting this answer? Second answer, D. Outer diameter should be higher than 125 that you got already. 125. I don't know. My values are running here and there. How much the answer now? Feeling sleepy? God. Ahmad, what is the answer you're getting? All of you switch on your camera. Maybe few classes I need some training to get used to with the tablet mode. Can you switch on your camera? What's the answer you're getting? You're not doing, just listening only.
190 mm.
Oh, very good. So should be higher. Now, are you getting the same answer? 190, 190 mm, 190, right?
Yes, miss.
Very good. So just apply the common sense, see whether it is, you get any fraction here, approximate to 190 point, how much is it? Point. Say some value you are getting, okay? 3, what is the answer? Can you get me the correct answer? 190 point? You're not doing. Let it be 20, for example. So you just approximate and have it as 190. Always check, apply your common sense. Outer diameter should be higher than this 125. So your answer should be relatively correct. Okay. Any question for the second? You want me to redo it? Well, it's very bad writing. Handwriting is too bad at this point. Any question here? If not, can we do the third question? I repeat once again, this was given with the tensile stress, direct one, and asked to calculate your diameter, outer diameter of the object. Okay, let it go on. Okay. So it's a direct one, no need to worry about much. Just work back to work from the answer given to you, which is your stress. You know the formula for stress. From there, you are rearranging and getting your answer for the diameter, outer diameter. Then moving on this question. This is very interesting and important one. Third type of loading you need to understand. Why I take a bit of questions so that you understand clearly the concept of loading and the stress produced so that you can apply in complicated problems. You see here very simple question given to you, another type. What force is required to punch a 20 mm diameter hole in a plate that is 25 mm thick? What kind of stress is produced in this operation and how much is the value in mega Newton per meter square? Solids you have to use mega. If it is the same m coming in liquids, you can use million. Okay, in doing this, very touchy. It's already in notepad mode. What's the problem? My mic goes and come back. Okay. Third type, when you want to punch a hole in a plate, you must understand what is the material on which it is acting. That is number one. Okay, material on which it is acting. Based on the material and the surface, you can classify what type of stress it is. See, you can see the cursor moving. There is a point. Can you move? Can you see the cursor? Huh?
Teacher, we can see the slide.
Oh, I didn't share it. Can you see now? Can you see the cursor moving? There is a black point moving.
Yes.
Okay. If not, you tell me. Whenever it is stopped, you tell me. Otherwise, I have to use other type of pointer. Okay. In this case, there's a punching happening, isn't it? as I said before, it is not only one type of stress developed, but the matter of which is significant for which you are going to design and which is going to cause the major failure. Accordingly, you need to concentrate on the design to complete your product. It may be a machine component or a building truss component, or maybe any component or a pipeline system or any other facilities that you are constructing. In this case, the purpose is to make a hole on this plate, right? Of thickness so and so 25 mm thickness. The plate is of 25 mm thickness. You need to make a hole on this, right? You need to know the exact force with which you can act on it so that you can make a hole. So how much is the load with which it can act? Is the load given to you? No. How much the value? Yeah, load is given to you, right? P is given. You need to find. This is the unknown, right? This is the unknown. What kind of, how much is the force that you can apply? Make a hole, a clear hole, because machines and all, you need to have a clear hole. It's not you cannot have undulations or a tidbit here and there. Otherwise, the fixtures will be in problem. Maybe leakage, maybe breaking, or not firmly fitted to the surface. To avoid all these things, initially you need to know how much is the force required to make a hole of this thickness. The material thickness is 25. The thickness of this material is 25 mm. Mind it, right? Okay. When this force is acting on it, you see the material got sheared. The material is getting sheared along the load of along the loading, isn't it? It is not a elongation, or it is not a extension away from the loading, but it is not a compression towards the loading. Rather, it is getting sheared parallel to the loading surface. You see, the loading is in this direction, the shearing also in this direction, right? The shearing is also in this direction. The material is get rid of in this direction, isn't it? Because the failure or deformation is taking place parallel to this loading, then it is called shear. And which surface is in action? Only this portion, right? Last time it is the whole surface, and the on surface. If it is a compressive stress, if there is a compressive stress acting on it, then you need to take the surface area of this material. Now it is only the whole of this much thickness. This much material has been removed due to this action, or the material is sheared from this puncture. It is called puncturing stress or shearing stress. You can see both are same. So the material is sheared out due to this puncture of thickness 25. So the action is towards this surface only, not on the surface. Do you understand this point? Although the force is acting on it, right? The force is acting on it. The shearing takes place along the surface to remove the material of thickness 25. Hence, this type of action and the deformation is called shearing stress. Okay. Let's write the given data. Given data. You are given with the diameter of the hole that is necessary to be made. Dia of the hole. Dia of hole. Hole is 25 mm thick. Sorry, 20. Yeah? Diameter is 20. 20 mm thick. Sorry, 20 mm you need to make. Okay. Thickness of the plate. T. Let it be T. If you want, you can write fully. Thickness of the plate. Thickness of plate. T is equal to 25 mm. Then what is given to you? We understand that this is a shearing stress because it is happening along the surface. It is not there is no reduction in the shape, or there is no extension of this shape on the plate, right? There is no extension, there is no reduction in size on the plate. Rather, the material is sheared out. Hence, we need to concentrate on the area as this circumferential area, not the surface area on top, right? Or the area you have to ignore the area perpendicular to the loading in the case of shear stress or shear force reactions. Okay, here the load is acting, it will act parallel to the shear stress will be produced parallel to the loading. or tangential stress. Others are longitudinal, right? Already we learned compression and tension or longitudinal deformation. This is tangential deformation or parallel to the loading or parallel to the surface, it will shear. Last time this is if it is a box, it will just parallel. Due to deformation, it will get shear parallel to the loading. The loading taking place like means the
Miss,
shearing takes place parallel to the
the shear stress is not given.
not given. Well, load is not given. Shear force is not given. Shear force is not given. Oh, both are not given, right? In this case, one moment, I miss out the data. One moment, I will check. Anyone have to be given for unknown. Okay, you can take the shear stress is given to you, right? You need to find the loading. One moment, let me take any one value. Okay, I give you the shear strength. You need to find the loading, because I already asked what force is required. Sorry, I need to edit this one. I will write here. I don't know why I cannot select this one. It's not how much. It's not how much. And the value, I just write it as thank you for correction. The value of shear, the value is the value of shear stress is in value of shear stress. Value of shear stress is it to be 350 meganewton over 350. Both cannot be unknown, otherwise cannot solve. We don't have equation, right? All right. I start from continue from here. Right. 350 Newton per the stress is given to you, right? The stress is also given to you, but shear stress notation is different. Tau. The T pen T shear stress also given to you. How much is it? 350 kilonewton over meter square. Is the point clear? I request you to understand at this point, because if you go for complex problems, you need to understand the type of deformation. That's why I brought in this question. There is no elongation, there is no compression, rather the material is sheared due to application of the loading and the material property to shear along the surface or tangential to the loading, right? That's how you can get the job done for making a hole, right? So the striped line, the striped lines are the area in action for shearing. You need to have only this area, not the surface area on top or perpendicular to the load. You need to ignore the area perpendicular to the load due to this shearing, because this shearing is, I don't say there is no compression, there is, but it is not significant or ignorable compared to shear stress produced. Okay, come on. Need to find out the force, how much force you can apply so that it gets sheared off, right? Solution. Go from the known data. Shear stress is given to you, right? Can you work out and give me the answer? You already have the answer with you. Carefully substitute the values. We are trying to find the P. Your required answer, if you want, you can write down the required answer. Always you keep one line on this. The required answer is P. Okay, P is not known. I don't know why my file is getting changed suddenly. Okay, solution. Shear stress is given. I can substitute 350. Always go with the unit per meter square, which is shear loading. I don't know how much is shear loading. Let it be tau. Tau. I write it as F. Shear load by the area. What is the area of contribution for the shear loading? Right. Can we expand now? For finding the area, I know the shear force. Shear force, you can conveniently write this V also. Normally you use the V as the shear force, right? That is also very convenient way of writing. V is the shear force. Area is the area due to the shear force. And then come on, find out the area. How much is the area? How do you find the area now? Better you find it separately, otherwise it's confusing. Can anyone tell me what is the area on which the shear force is acting? circumference only, isn't it? Only the circumference. How do you find the circumference? Pi d, right? Circumferential area, not surface area, not the cross-sectional area, but circumferential area. The circumferential area will give you this one, but it is not on the surface only, but to the thickness of 25. Hence, I can write pi dl, pi dt, pi dl or pi dt. We can put pi dt. So it will be pi times diameter of the hole that you are making is 20 mm. Let it be 0.2 meter times thickness is 0.25 meter. Can you give me the answer? Are you following? Okay, what is the answer? Only the circumferential area in contact with the material is removed. So you need to, the force is acting around this area per meter square. Come on, how much is this?
1.57 times 10 to the power of -3.
Okay, meter square. Now we can conveniently find the load. I don't know the load, just rearrange this equation. V is equal to tau times AF. So tau is very bad. Tau is okay. My tau, the value of tau is given to you 350 kilonewton. I changed to newtons. Newton over meter square stress into area. I know 1.57. Please correct me if I make mistake. Huh? Okay. How much is the shear force? Find out the shear force. No answer?
549.5.
Very good answer. I'm also getting same 549. Otherwise, I make it as mega newton or megapascal. Okay? No, not Pascal, mega newton. Alright? Oh, better write it in newton. It's not mega newton answer. How much is this one? The question given kilonewton, right? Or mega newton? Sorry, there is a mistake here. Mega newton means 10 power 6. Please correct here. Mega newton 10 power 6. You need to substitute 10 power 6. Rework and get me the answer, please. Some point value correction is here.
Into 10 to the power -3. 5 plus 3.
Yeah. Others, get me the answer. Let me join. I don't have the list of students here.
549.85 kilonewton.
54, correct answer. 54. 549.778 point. What do we?
Kilonewton.
Sorry, 549.778. Okay, 0.71 newtons. Correct? Correct? Or 0.4, 0.5 mega newtons. Clear? This is comma, not point. I'm getting this answer. All of you getting same answer?
Yes.
Okay, very good. Let's move on to the next question. Any question here? Do you understand?
The answer is 549,500.
Okay, around this is okay. Around this is okay. Fine. No problem. The fractional part, maybe you miss out some fractions above, it will be carried over. As long as you reach 549, it's fine. Okay, come on. See, 3 types of questions we have seen, right? What is compression? Towards the area. Compression means it's still inside the material. It is not bringing the material extending the material, but compressing the material. Okay, the load is such a way that it compresses the material, and the body have to act in the opposite direction, right? Then it is a compressive stress. In the second case, it's a tensile stress. It is acting at the end of the body, right? It is all on the body only, on single body only, right? This compression and tension, if one word you can say, it is on the single body which is acting either inward or outward. If it is inward, it is compressive. If outward, then it is tensile stress. Sometimes in the question they will give you explicitly it is acting, tensile force is acting, compressive force is acting. Otherwise you need to understand the question and answer. In this case, if you see, there is no elongation, there is no deformation in terms of reducing size or increasing size. Rather, the material is removed of certain thickness, right? Certain thickness and all along the circumference, right? Or throughout the circumference, sheared off, material is sheared off. Hence, the force that is acting on the surface per unit area, which causes the material to be out, is shearing force and the corresponding shearing stress. That's why we treat it as shearing stress. We substituted the formula for shearing stress, rework to get your answer for the required loading. You need to apply. This is Newton, right? Kilonewton, meganewton. 0.5 meganewton you have to apply to get this done, this much material out of the plate for the purpose of manufacturing or creating a required components of the building or a machine and so on. Okay, any questions so far? Shall we move on to the number 4? Fourth question. Any question? Very simple one. Let's try this one. Given data. Start with given data, free body diagram, right? If necessary for finding unknowns, you have to. What is happening? Okay. A hole is to be punched similar to that one, but indirect in a different. You need just rearrange the same procedure. Just rearrange, you will get your answer done. Okay. Herein you are given with the same type of question, making a hole on the plate, right? Shearing strength of already given, the stress is given to you, 276 megapascal or 276 meganewton over meter square, or 200, you can say 10 power 6 also fine, or just say megapascal. Okay, it can also be written as 276 into 10 power 6 pascals, okay, or Newton per meter square, also fine. Any type you can write down. Okay, and the compressive stress in the punch is limited to this value. Okay, compressive stress is given. Now you are going to do two things. As I said before, any operation will have any type of or combination of stresses produced. These are all the resisting moment or resisting force per unit area due to the material. It might be compressive, tensile, or combination of this. In this case, there is a shearing and compression. This is 1 and this is 2. Two operation happening. And the stresses, corresponding stresses are given to you. You need to find. You need to find. Okay. You need to find how much is the thickness of required. Okay. Now the thickness is not given. How much is the thickness required to be designed to make 65 mm hole on the plate? Okay, how much thickness is required to be designed to make a 65 mm hole on the plate? If thickness of the plate is maintained at 8 mm, okay, so this thickness is not given, okay, but diameter of the hole is given. You need to make a diameter of 65 mm hole. Maybe this diameter is 65 mm is given to you. Diameter of the hole is given to you in the first case. I'm talking about the A, case number A. For case number A, load is not given, but the stresses are given. Diameter is given, thickness is not given. You need to find out. Same method of working, but you rework to find the required answer. Let's do this one. Write the given data. Same procedure. Can you all work with me so that we can check the answer one by one? You are given with the stress, normal stress or the compressive stress. Compression and tension are normal because it is perpendicular to the surface on which it is acting. On the other hand, shear stress is tangential or parallel force over area, hence it will be parallel to the area of application, okay, or point of application. Please remember this point, right? Having understood this, let's work out the number one. You're asked to find how much is P, right? How much is the P value, right? The stress is given. We work from the stress value. How much is the stress given to you? Number one, I write the given data. Shear compressive stress is given, right? Compressive stress. It is already given that if the stress are given to you, you can take it because the material is loaded to the extent of producing a compressive stress which is equal to megapascal. Okay, due to this loading, the material is produced. They measure the compressive stress using the machine, the meters. They found to be 344 megapascal, and then we work one by one. These two are your answers. Okay, two one by one. Let me take the compressive stress first. Maybe second one. Okay, because I need the loading, so I go by the known value. 344 is your compressive stress, and then what else? Area is given. Area is convenient to calculate because diameter is given to you already, right? Diameter of the hole is given to you. So from the known data, I can conveniently find my P, right? What are the other data given to you? Diameter, diameter of the hole that is to be made. Dia of hole, okay, to be made is equal to. Go from the known data, we can find the unknown, and then required data will be. The required data is to find how much is P, isn't it? Required data is to find how much is the P value or loading. We don't know yet whether this is costing the compression or shear. Let's find the P value based on the compressive stress given to you. If it is a compressive stress, the perpendicular, the area on which it will be acting is the cross section or surface area of this material. The diameter of the material is given. It has to work in this area only, not the whole plate, right? To the length of the diameter of the plate, I mean the hole that is required to be made, right? Okay. We'll write the formula solution. We can work out the solution same like the last time. Shear stress is equal to force over area or load by area. Okay, it's very touchy. Okay, and then I go by the formula, which is I find the area. Area is convenient because circular, right? The whole diameter given means it's a circular. I use the circular formula. Stress is given, right? 344. Let me substitute the value. 344 megapascal. Maintain the unit. Otherwise, you'll have wrong answer like the last time we did. 344 megapascals. Megapascal. Better you write with the unit. Load is to be known, and then area is pi d square. Diameter is 0.65 mm, right? If you don't know, just do it. Divided by how much is the thing? 1000, right? So 0.0 mm, right? 65 mm. Then 0.65. Wait, I remove this. Divided by 1000, it will be 0.65. 0.65. Okay, to change to meter, 1000 meters equal to 1000 mm equal to 1 meter. So I do it this one. Pi d square by 4 is my answer. Can you give me the value of the compression loading? How much is the value?
1.14 megapascal.
All are getting the same answer. Keep it as a megapascal because we don't have any other thing. If there is any other loading coming in, you need to have similar units. Okay. Are you following, everybody? Okay. Let's proceed with next one. The next category, which is shear stress. That shear stress can get you because shear stress is acting to get the see here thickness from this question itself having the answer. The thickness is matter when there is a shearing happening, because the area on which the shearing takes place, shear load is acting, will be the throughout the thickness to take out the material or shear of the material, right? So by using this shear stress, I can find the unknown thickness. Okay, let's go on finding the shear stress. Second part B, shear stress. Shear stress is given to you, tau. How much is that? Shear stress is 276 megapascal. 276 megapascal, right? And what are the other dimensions? Diameter of the hole. No, you need to find the thickness of the plate at 8 mm. Then determine the smallest diameter of the hole that it can be made. Okay, so sorry, thickness is given. Thickness is given, right? Okay, where is the eraser? Vice versa, if thickness need to be found out, you can still use the shear stress. The corresponding diameter, if thickness is given and the corresponding diameter you need to know, still you can use shear stress so that you get the answer for unknown. Right, I go by this way. Read again now. If thickness of the plate is 8 mm, thickness is given, right? Thickness of the plate is given. All right, once again, thickness of the plate is given. One dimension of the shear stress area is given to you already.
Miss,
Huh?
for question 4A, is it want to find the thickness?
Let me check. Question A is what we confused already. One moment. Oh, then we cannot stop until P. We need to find the thickness. Okay, let me finish this. Yeah, same procedure only. I'm doing the same thing. For this loading, we need to find the thickness, then apply. Treat this as a shear force, should be equal to the shear force, then only we can find out. So this is the value of the shear force which is acting. This is equal to the shear force, okay, or VF, shear force. Let's find out the value of the thickness for the A, case A. Shear stress is equal to, if you take the shear stress, there is a thickness, there is a, you need to find out the, let me write here, also T, you need to find T as well as P, okay. Once you get P, but I find from the compression, right, one moment, a bit confusing. I find from the compression, but that is the value which will be used for together as a combined value. It's a combined value. This load is causing compressive strength of, this is only the material property they have given. The load is acting and it is puncturing here, right? Okay. So we got the load like the last time, here in this case, similar to this case. You have the loading, you can find the thickness or diameter, isn't it? In this case, what you did find? Load. Having given diameter, thickness, you found the load. The reverse, now is the reverse. Follow the same procedure to find the case of reverse. Forget about whatever the data given. Okay. Sorry, I misled. You can put here itself as the P. Okay, but the diameter thickness is not known in the beginning of the this case, but only the whole diameter of the hole is given. So we assume to be P is equal to VF or shear force. Okay, VF over area. Okay, this is the one going to give you the thickness now. Substitute the value. What is the shear stress? As given already, right? How much is shear stress?
276 megapascal.
Right, with the unit again, megapascal, and then we know just now we found 1.14 megapascal. Area because shearing, right? Please be careful, follow the question and answer. You are given with how much maximum thickness it will be required to design 65 mm hole, right? So if you take out that material out, right over here, if you take out the material out, it will have 65 mm the whole diameter, right? 65 mm, and this one is not known, right? You need to find the T. So can you substitute the value now? Pi, how much is the area? Pi 0.065 times T. Good. So you can find the unknown already. Times T. From there you can find the T. Because we don't know the values, you just go from the known one, you will get your answer. What is the answer? Mm, get me in mm.
0.02.
Wait, I will enter the. My keyboard is missing again. Got the keyboard. Any other answers? All are getting the same answer?
20 mm.
Need some more time? 0. You want to give it in mm or meter? You will end up with the meter, right? Because I substituted in meter. When you solve this one, you will get it in meters. Megapascal cancels. So undo. Megapascal cancels on both sides. You will get up with meters. Rearrange and get me the answer.
0.02 meter.
0.02 meter. All are getting the same answer? Check, please.
Yes, miss.
Okay. Let's proceed. So, how much is the mm? Mm value. 20 mm. And let's check. Last time how much? Around this one only. 20 mm, reasonably good. Not a very bad answer. 20 mm. 65 is still okay. You can imagine what is 20 mm, right? 2 centimeter thickness of the material is sheared off. Okay, makes sense. Any question in this? I repeat once again. Initially, we don't have a data, right? But you are given with compressive stress and shear stress, right? Because I don't know which load is it, right? Whether it's producing the shearing stress or compressive stress, we do not know the value. Oh God, you cannot see the cursor moving. Maybe my hand. Oh, you can see now, right? Oh, I need to touch on the arrow every time. Okay, this load is causing a type of stresses are given. Many unknowns. 1 and 2 unknowns, right? To find first unknown, we follow the formula for compressive stress, right? Compressive stress is like this, and then substitute the formula so that you can find out the load. We found the load and we equate that load and assume to be we have to make the assumption. Assuming that okay. Very touchy. Based on the P I found, I equate that P to be V, right? I will make this sentence and then only the answer will be valid. To be VF, and then from the answer given to you on shear stress, right? This is the shear stress, right? Shear stress is also given to you, or shear strength is given to you. I use the formula to find out my unknown, and if you substitute the shear strength, the area in contact with the surface will be like this. This is the area, right? This is the area, this thickness and this diameter. This material will be sheared off. This material will be sheared off. Arrow is not coming here. This material will be sheared off when it is punctured, right? So I follow these dimensions of thickness and the width. T as my thickness and the width of this puncturing. I got the answer for 0.02. All are getting the same answer. 0.02 meter, 20 mm, approximately 20 mm. If you have points and all, you make it as approximately 20 mm. All right, shall we move on to the next question? Are you there? Last question, this important question that we left last time, I want to complete it. Having understood what is shear, what is compression, what is tension, and the surface on which it is acting, which is most important. That's why I worked out a few questions on exclusively on different types of stresses. You need to understand this one here. Last time we already read this question, isn't it? There are two planks, right? There are two members connected by. Can you see the arrow moving? You can see now, right? There are two planks given to you. Maybe you have a balance or some kind of portal which is going to support or hang something at the end, right? This is the frame and this is one frame, and these two are connected by these links. They are called links, right? The question given is the point of interest, the unknown. I don't know where is the red color gone. I don't have red color today. Let me use the screen. The point of interest is here only. All the unknowns are asked at this point, okay, or for this link, okay. You're asked to find, one moment, let me read from here. The dimensions are given to you, right? The dimensions of this one, depth is 40 mm, right? 40 mm. All goes to, all are uniform material, uniform size, 40 mm. And the thickness is also given to you, right? Thickness is given to you. Thickness of the material is there like this. Thickness is 10 mm given to you already. 10 mm also given. And then ultimate strength, tensile strength. Tensile strength is given. Okay. Tensile strength of the body is given to you, which is 400 megapascals. I will write later on. Let's understand the question. And then while each pin at C and F has diameter 20 mm. Diameter of the pin also given to you, 20 mm diameter, diameter of the pin, and are made of steel with the ultimate shearing strength. Shearing strength is given to you, 150 megapascals. 150 megapascals given to you. Determine overall factor of safety for the links CF. Only CF, the point is given as a CF. Okay, let it. Point of interest is the whole thing. Your unknown is here. CF. Determine the overall factor of safety for the link CF and the pins connecting them to the horizontal member. Okay. What are all the safety factors that is to be considered for designing this member CF, which is having a pin, which is having a link, two links. Please note this. Two links are there. You have to be carefully checking this diagram. I bigger the size. There are two links, one link and another link. This frame, okay. When you go into the line sketch, you should be clearly understanding and imagining and understanding. Then only you can draw a clear line sketch. I repeat once again. There are two frames connected by two links. In this question, you are asked to find what is the factor of safety in designing this link. Okay, how much is the factor of safety to be adapted to have so and so shear strength and tensile strength. Okay, sometimes the factor of safety is given, asked to calculate either your tensile stress, or this may be the question mark sometimes, or this may be. In this case, reverse. Factor of safety is given, you are asked to find how much is the stress is given, asked to find what kind of factor of safety you can design. So, what do you mean by the factor of safety? First of all, what do you understand by the term factor of safety? Let's understand one by one. What do you mean by factor of safety? Factor of safety.
Ultimate stress over allowable stress.
Yeah, in other words, maybe if you are not clear with the, if that English term is confusing, strength over stress. Okay. This is the capacity or capacity over demand. The classroom can accommodate only 200, but the demand is 300. You will have a problem, right? Okay, capacity over demand. Simple words I'm explaining to remember this meaning. Sometimes I also get confused. That's why I have to be writing in simple English. Strength over stress. Capacity over load. Supply over demand. Capacity over demand. So capacity should be higher or demand should be higher. Quickly. In any design, for a successful, safe design, strength should be more or stress should be more. Answer Mila, I'm going to finish, don't worry. Strength should be more or stress should be more in any design?
Strength.
Very good. This should be higher, isn't it? This should be lesser, right? Yeah. That's why always factor of safety is greater than 1. Factor of safety is always greater than 1 because of this equation. If you have a higher capacity and the demand is so and so, you are still accommodating, isn't it? That is why you need to have this factor of safety always higher than 1, which is normal case. I already told you in RCC design we use 1.5. In these trusses, they may go to 2.5, even 4 also they can keep. Okay, these are all the theory about factor of safety. After understanding what is factor of safety, let's solve this problem. I repeat once again, you are asked to calculate what is the factor of safety for designing this CF member. Okay, CF member. All of you please try to understand the question given here. There is a pin here. Take that out. There is a pin here. There is a pin here. Pin, pin, pin. Pin. Okay, there are many pins here. No fixed support. Clear? So forget about moments. Okay, there is all free to move. Moment 0 means free to move. Moment is not restricted, right? But reactions will be there because of the pin. And you're asked to calculate for this member. You are going to design this member only, right? When you found the failure at this point, you can find the answer for this. Okay, due to this loading, what will happen? This member will respond, isn't it? When this is pulling down here, this will try to go up, isn't it? At the same time, because of these two pins, it will try to come down such a way that these two are balancing for this download action, download loading. So as a layman, you can understand and recognize, or what do you call, imagine what will happen if this loading happening at this point with this pin, pin. Okay, having understood, let's take the point of interest is at designing CF. Two members, this is one. There are two members, note this point. This is one and this is two, right? Number one and this is number two. Okay, two members are there supporting this frame. Okay, let me move on to the solution. In finding the factor of safety, I know the formula is 10th over, go from the solution. I have written all the data here. Please follow the practice of writing given data. You do it. Now let me do the solution. You go from the known value, which is known to you, factor of safety. Factor of safety, you need to find out. Where is it? Yeah, you need to find out. Okay, factor of safety. Factor of safety, what is the formula? By the one strength to cells or ultimate strength by allowable strength or designed strength. Let me write the word, same word in your notes. Ultimate. Give me 1 minute. 1 minute. I need to change this one. Where is it? Often get stuck.
Means you are muted.
Sorry. Okay, let's continue with this. I write the usual formula, ultimate stress by allowable stress, easy for me to work out the answer. Okay, ultimate stress, or if you want to compare stress, otherwise load. Okay, in this case, what is the load is given to you already, right? You can compare between these two, ultimate and allowable. I just put it as allowable load. Okay, let's find out one by one so that you get the answer for your question. I do step by step. Start with, do you have this one? Yeah, you have this one, but your point of interest is at F. You need to find out how much is the reaction force. That is your load, isn't it? How much the reaction created here, that is your load at which it is acting against this loading, or this is the design load to be considered for designing this member. Let's find this unknown. Come on. First step, to do the unknown, let's draw the line sketch. I take only the bottom member because my point of interest is only at that point, which is E. This is F. Okay, don't worry, the action at this point C will be carried over to F. Okay, hence I follow bottom member only, which is significantly, which is helpful for finding my unknown. Very touchy. Okay, the load is acting downward, isn't it? 24 kilonewton already given to you, which is this point G, right? EFG, right? Because of the loading and because of this frame, okay, there will be a reaction, and because it's pin point, I can find out the unknown. I can find out the unknown. Where is my cursor? Gone down. It's now let's take the moment about, because I need to find out how much the load created here, right? The RF. To find the RF, I can use this equilibrium equation, applying equilibrium equation at point E. That means all moments about E. All moments about E is equal to 0. I follow this equilibrium equation so that I can find the unknown. Because pin joint, moment should be 0, right? I follow that criteria, or what you call degrees of freedom. Then I follow from E. If you follow, what is the dimensions given to you? 0.4. This distance is 0.4. All in meters, right? 0.25. Okay, it is already given to you in the question. 0.25. This dimension is 0.25. Okay, so what will be the follow the notations of clockwise, anti-clockwise that I teach you last time about E. If you want to find about E, you fix the clock here. Due to 24, it will be positive or negative. It will be positive or negative. The 24 will rotate this in about E. Rotate in clockwise or anti-clockwise. Answer Mila. 24 times positive or negative?
Positive.
Very good. Clockwise, keep the clock here where you want to find out. 1, 3, 6 and 9. It is like this in the direction of the clock, isn't it? So this will rotate like this. So 24 into 10 power 3 newtons. I changed to newtons better. And then what else you have? Distance is lever arm is 0.65. This is 0.6, 0.25 plus 0.2, 0.4, 0.65. This load done. What is the reaction? Positive or negative? This is clock. This is the clock. When you go this way, it is positive or negative? Anti-clockwise, negative, right? So I write it as RF times, RF is unknown, times what is your lever arm? 0.4. Did I calculate all the loads and reactions? Yes. So I find RF is equal to, how much is the value RF? How much is RF? Give me the answer, please. RF?
39 kN.
39 into 10 power 3 newtons. Okay, let it be kilonewton or newtons. If you don't use 10 power 3, put it as kilonewton. Right, I got one answer. I got the load, the reaction that is taking place. Load is gotten already. You can now design that member. Come on, before designing, I need to know, when you are asked to find the factor of safety, right? The ultimate answer is factor of safety with which it is acting. So this is the load. This is the load that is coming, or this is the reactive load that the member have to respond to the load that is acting at 24. Do you understand the answer of this RF? So this is the reaction produced due to this loading at this point. You're going to design for this loading. This is your design load or allowable load. What is its ultimate strength? That you need to find out based on the material property or the material with which it is designed. When the material with which it designed is very heavy and higher than this one, your member is safe. With that you can find the factor of safety. I repeat once again, this is the load, the response of the material due to the external load that is acting at 24, this one. Okay, when this load is, this is a design load or allowable load for this frame, for this structure. Now let's find the working load with the actual load or the capacity of the material based on the material by virtue of its material, like breadth and depth is given to you, right? Or the dimensions are given to you. Based on the dimensions, let's find what is the capacity of this member to withstand this loading. Come on, let's do that. Start with, there are two things here, right? Please recall the questions that we have done with just now. You have two portions, right? There is a hole, right? I mean the what do you call, the pin of diameter, certain diameter, and also the link. Note this point. Hence you need to find for both of them one by one. Let's start with finding for the pin. Sorry, links. Links is the big one. Based on the, is the link is subjected to tension or compression or shear? Answer me. That's important, right? To find out the known. The link, CF is subjected to, the link CF is subjected to tension or shear or what? The link is subjected to, due to this loading, tension. Okay, I use the same word. Based on tension in links, the tension. Let's find out the tension loading, tensile force, and the unknown is tension or tensile force, tensile force or tension in link CF is given by, okay, we're going to find this one. We're going to find this tensile force or tension in link CF. How much is the, for finding this one, you are given with the stress already, correct? To find the load, you are given the stress already. With the stress, I can find this load, right? But I need to know the area. Am I right? Okay. What? How much is the stress given to you? Let me check the number there. 400, isn't it? This one. See, tensile stress is given to you already. Go from the known data. I need to find the tension loading on this member CF, but tensile force is given to you already. Go from the known data, which is tensile force, tensile force or sorry, tensile stress, tensile stress, which is sigma T is given to you. How much is it? 400 megapascals. Let it be in the same unit. I changed to all pascals. 400 megapascals. I changed to pascals. easy for us, because later I end up with your newtons, because I already have newtons here. So this is the value given to you as megapascals, and then we need to find the load, right? Write the formula for this. This one is tensile force, right? Tensile force, which is P, let it be tensile force divided by area due to the tension, or area subjected to tensile force. Area subjected to tensile force. Let it be AT for better understanding. Okay. I need to know this PT only, right? The load, how much is the load that can be borne? 400 times 10 power 6. I don't know AT. Let's find AT. Area on which the tensile force is. Area on which the tensile force is acting. Let it be area is equal to, AT is equal to how much? Area, draw the diagram separately, then you know how much the area, right? I just take the bottom member only, right? I take the bottom member only, which is E, F and G here, right? So at this point, if you go to the diagram here, this portion, right? This is the portion subjected to extension, right? Only this portion is subjected to the extension due to pin. And because of the pin and because of this loading, it will get extended. If you take that particular cross section only at this point, if you do the cut section, you can see like this, a small section with the, better I draw a bigger one, zoomed view. Okay, you can see a bigger dimension like this, and this with this, how much? Anybody? I'm at F, at point F, I'm drawing the cross section, cut section at F. How much is the depth? 40 mm, right? And then what is the diameter of the pin? What is the diameter of the pin? 20 mm. Are you there or slept? Are you there?
Yes.
Only one voice I can hear always. Please answer my question. What is the diameter of the pin? I mean, sorry, pin, it is pin. I go up here. See here, it is already given. Diameter of the pin is 20 mm dia. Okay, in mm, careful, don't forget 0, 0. Okay, all given. So the tension is acting on this, right? Tensile force is acting on this. Although I put it as a middle one, but it is as though, wait, I better I remove this, otherwise you get confused. It is acting along this surface, right? So it will be, if you take the net value of this one, it will be B minus D into T. In other words, what is the breadth? 40, isn't it? 40 mm, all in mm. I have to go from here, I don't have space. 40 mm, 0.04, 40 mm minus diameter. You need to deduct the diameter times the thickness. 0.0. What is this? How much the thickness? We go back, you can check. How much the thickness? This thickness.
0.01.
This thickness, or I take the arrow. This thickness, this thickness, it's already here. Take one flank, one link. If you draw one link, I draw the link also. The link is like this, okay. And the thickness, okay. This thickness is 10 mm. This thickness is 10 mm. So this is the portion subjected to, right? Hence the thickness will be 10 mm, which is a 0.01. Okay. Now I got the area. What's the answer, please? What's the answer? We're going to finish the question. Calculation. 200 times 10 power minus 6 meter square is my area, AT. Okay. Are you there? Then proceed with, I got the area. Let's substitute in the stress there, so that I can find the load. Substitute in this equation. Where is it? This one. Substitute in 1. in 1. If you substitute in 1, you will get, you don't know PT, bring the AT this side, bring the AT this side, 200 times 10 power minus 6. Get me the answer, please. 6 is get cancelled. Very simple one. What's the answer? Are you there?
80 kilo.
80 kilo or 80 into 10 power 3. But this one is supported by this link, right? But you asked to calculate for the whole overall factor of safety for the links and the pins here. The frame is supported by 2 links here, right? Can you see the arrow? 2 links are here. It's not one link that is supporting or subjected to tensile force due to the loading. There are 2 links. So the total effect will be combined effect of these 2 links. Due to 2 links, you need to multiply by 2. The tensile force cost will be due to 2 links at CF. You need to multiply this value by 80 times 10 power 3. Will be how much? 160. Total tensile force will be 160 into 10 power 3 newtons. Is this answer clear? This is the total loading that is acting. Okay, I keep it as force. Total load because I already
Miss,
using.
I think should be divide.
Why we divide? Why we divide? It's additive. How come it's divided? Total load, total tensile load, right? Tensile. Come on. Load or tensile force. Tensile force. Force is convenient word. Force. Why it is deducting? Answer me. Explain me at this point. I use this diagram. There are 2 links, right? Why you need to deduct? If there are 3 attached to or this side 2, multiply by 4. If only 1 link, there is no supporting on the other side, just live with 80. Okay? Correct? Shall I proceed?
Okay.
Good. Because we are talking about CF. We are working at CF. We found the load. I got the load, I mean the tensile load, that is the capacity. In other words, the capacity at this point. Can we find the factor of safety for, can we check the factor of safety for the link? Factor of safety for the link. What is the formula? I told you already. It is actually force, ultimate force to the allowable force, or what do you call? That will be allowable force. What is the first one? First one we got it as how much? This one. Where is this loading? This is the one. The reactive force that is to be borne by the member CF due to 24 kilonewton acting at the point. This is the thing. This is the reactive force, or the force that is the designed force, allowable. So that will be, I write here, 39 is the allowable or required one. Required, let it be required. 39 over 3. And then due to the material property, we multiply all this thickness, area, right? This material has the capacity of bearing about 160 kilonewton. Sorry, Newton or kilonewtons. Let's find the factor of safety. What is it?
4.1.
4.1. See, so very. You should not always be over designing, and sometimes the engineers do this job. But here we are finding it separately put together, maybe a simple, agreeable. So the ratio is 4.1, 4 times higher you are designing. your member that you are constructed having the capacity to bear 160, but the overcoming load and overcoming reaction is only up to 39 kilonewton or newtons. Okay, the factor of safety is 4.1. That's all right. This is at CF or the link. Let it be link. CF got link and points. Add the link. The answer for the link. Let's find for the pin. Can you do for the pin the same procedure? You need to see. You know this point, right? You are going to find out what is this at the pin. Can you find out? I wait for you. Wait for 2 minutes. Just same procedure. If not clear, ask me. Same procedure like you did for your links. Tension was created at the links. When you go to pins, it is a shear. So what the sentence I use here? Tensile tension in a tensile or tensile force in links. Now is a shear in links. Shear using shear in links. Shear in at pins or shear in pins. Shear in pins. The second part, we are checking the factor of safety of this design. Okay, shear in pins can be calculated. What is the value given to you? Shear stress. How much is it? Shear stress is equal to 150. Okay, 150. Okay, let's find the shear loading or shear force in the. Better write shear force. Shear force in the pin at the pins. Shear force at the pins. At the pins. At the pins. Let's find out the shear force due to the material at the pins or due to the pins. Come on. Go by the pin diameter, everything to find the shear force borne by this pin. A is equal to, you need to find the area, right? Because you have been given the shear stress. How much is 150, right? Please correct me if I'm wrong. At the pin, let it be P. How much is it? 150 megapascals is given, right? 150 megapascals. You need to have patience to understand. Once you understand, you can apply a similar way in other questions to make an attempt first. These days, make attempt, then you get familiarized. If never put attempts, you cannot get familiarized. 150 shear stress already given, right? Now we are going to find out the shear force based on the material. Okay. Last time we found based on the load, that is 39 already found. Now based on the material, let's find the stress is given. I need to find the when the stress is given by shear force and shear force V and V at the pins divided by area at the pins equal to 150 megapascals. Let's expand for area. I don't know how much is the area. Let's find out the area. It's running out. What's happening down? Can you do it yourself? I'm also working out here. Trying to get the enter button. Oh, I make mistake. I like the con dot. Okay. It's not selecting here. Okay. So we need to find this loading. VP, yeah. Before that, I need to find area because the material properties are given. I can find AP. AP is equal to AP, yeah, pins area. What is the pins area? Pi d square, and it's a diameter is given, so I can conveniently find pi d square. But for the whole pin, the whole pin is shared. So the whole pin diameter pi into diameter. The circumference from 0.02 square by 4. What's the answer? Please give me the answer. I got the area. Are you getting this answer? All are getting this answer? I got
Yes.
the pin area. Now let's find the load. Conveniently we can find the load. And load also again double times because double links, double pin. Okay, both sides. Right. I got the area. Now I substitute the formula. What is that? VP. My VP is equal to 150 megapascal. I changed to pascals. Megapascal. 10 power 6 pascals are convenient for me. Pascals or newtons, newtons or pascals. Times, better newtons, because I get all the numbers in newtons. Newtons or pascals, both are same, don't worry about it. Newtons times, my load is here, times, correct, 10 power 3 pascals, 10 power 6, correct, times AP, AP is 314 into 10 power minus 6 meter square. Get me the answer, please. What is VP? For one pin, shear force.
It will be equal 47100.
What is the unit? Unit newtons. For double pins, for two pins or for two links, for two pins, you need to multiply by 2. Shear force or total force is equal to 47100 into 2 will be 94. 94 will be 94.
94.2 kilonewton.
Correct. Or I put it as all in newtons, correct? Right. I got this. The material property, out of material property, this can produce this much stress, the load. Hence, I can find my factor of safety. That is our point of interest, right? So, factor of safety for the pins, it is for the pins, shall I speak? Ultimate load at the pin divided by the allowable load, or just allowable already we found, right? This one 39, okay, and this, okay. So ultimate is this 94.248 into 10 power 3 divided by allowable is 39 times 10 power 3. What is the value? With this our answer is completed. I found the factor of safety with which it is constructed at the 2.42, isn't it? Okay. This is how you have to determine. If you want, I can repeat this one. The link will work out simple. Again, I know where it is started. Any question you can ask me? Any question? I stop here. Any question you can ask me? I have posted some questions in your notes. All of you start working. You have to put effort, not me. All questions done by lecturer. Okay. Any question? If not, I stop here for today. Thanks for attending the class today. You have to work out all